Hello guys, Ankesh again. I hope you are doing good in your life and you're all happy. I hope that you're all enjoying your life. I am again back with one more microcontroller, a new microcontroller this time from a company called NRF, and I have brought this controller in today's video because this controller is becoming very popular in the IoT devices because of its very low power profile, and it helps for longer battery backups, and a lot of people are using it for their IoT based projects where power consumption is a primary factor. So this session is probably not about the specifications of NRF. This session is focused more towards the programmers who want to start programming in NRF, and I'll quickly get you acquainted with the build system of NRF. So for the first time when you bring NRF into your lab or in your place of work, how to proceed with it, I'll just give you a quick glance about it without wasting much of a time. Now I have already downloaded the SDK and installed it in my system. I'll show it to you. So I'll open my terminal and simply give you a glance of my home drive. So I have installed two versions of toolchain. As you can see, there's a folder called NCS in the top row, and just right below it there's another folder called NCS-v3.2.4. So the first one is NCS v3.0.0 and the second one is v3.2.4. Unfortunately, v3.0.0 did not support some of the applications that I was building on NRF, so I had to update it. So right now I'm working on this toolchain, NCS-v3.2.4. So today's introductory session will be on this version of SDK and toolchain itself. Now NRF provides its SDK through their website itself, and the NRF SDK gets shipped with an auto system which is called as Ziffer. It is quite popular for other target boards as well. So the entire NCS framework revolves around the Ziffer framework itself. So we have to download both of these to make the toolchain work. If you follow the official flow of downloading through the official NRF app, then it downloads automatically to your system and configures it for your build environment or for your IDE. But I have followed a more traditional approach, which is usually followed by the conventional embedded developers. So I cloned the image of the NCS-v3.2.4 and it resides inside the folder. As you can see, I will simply take it inside. So the toolchain is downloaded here, and this is not the toolchain, this is the software framework. This is the complete hardware abstraction layer that is provided by the NRF. So as you can see, it contains folders as NRF, which hosts a couple of libraries. Then we have a dedicated driver library called NRFX Live, and then we have an access system or an abstracted top layer of the Ziffer framework, which resides inside another folder. As you can see in my home page, two folders are there for Ziffer: Ziffer-SDK-0.17.2 and Ziffer-SDK-0.17.4. For now we are using 17.2. Why? I'll just show you. But for now you can simply keep in mind that the complete toolchain binary resides inside the Ziffer folder, which is in my home directory. I'll show it to you. Let's go inside the directory. Ziffer 2.2. So you see, we have the toolchain here in front of us, which resides inside this zipper installation, while the abstracted access layer is present inside the NCS software framework. So you can see the binary is actually completely separated from the software framework in case of the installation of NCS in your laptop. At least I can say this for the Linux version, because I primarily work on Linux. Now let's go back to the software installation directory, which is NCS, cd NCS 0. So by default, like other microcontrollers, this software installation also comes with a host of example or sample codes. We'll quickly see the location of these example codes in the installation. So we get examples from two separate sources here, one from the developers of Zipper and one from the developers of NRF54L. So first I'll just show you the examples which are present in the NRF54L. We'll go inside the NRF folder. In NRF you can see samples. Inside samples there are a host of applications which are already there, which we can build and flash it onto the target code and use it. These are NRF specific build examples. While we also know that Zipper is used in many other target boards as well, including STM and other very popular controllers like ESP. So those examples are target specific. Some of them are target specific, but if you go with the common protocols, they primarily run in almost all targets. In our case today, I am using NRF54, so we'll just quickly go through that Zipper folder as well. CD Zipper. Where is the sample? Yeah, we have samples. So you see we have the hello world located here. Now for building the code or for building an application in NRF, you require something called REST that automates the CMake build system. It basically sequences the CMake commands which are needed to properly compile all the source files into object files and then finally link it to the Zipper linker that we saw inside the Zipper SDK. So first, for doing it, for REST I haven't installed it globally in my system. As you can see, if I type REST here, it will show me. Yes, so what I did, I actually created a virtual environment in my system. That environment I have created in my home directory. I'll simply start that environment. So dot source so now the environment is activated. Now I can write this version and it will give me the version. Now our build system is ready, and I have also provided path to the installation inside my bash.rc. I can show you that as well. Sorry, my mistake. Here you can see the path is exported for the NRF54L. NRF54L is the primary application required for flashing the binary onto the controller, and the same tool is used for doing the monitor as well using the tab. So I have exported the path for my toolchain. As you can see, it's in the last line export zipper underscore SDK underscore start or home zipper SDK 0.17.2. That was the directory which we saw where the toolchain binaries were located. Yes. So in this way, my complete build environment is already there. Now I have to tell you the command which you need to write for building a program. So I am already inside the hello world directory. I'll simply write west build Oh, before that, in case of West, you have to provide the target board as well. And for knowing the available targets available in your installation, you can type West boards. So it will give you a list of boards which are present in this installation of toolchain. So in our case, I am using NRF54. It should be located here somewhere. So I am using this one for my example here. So I'll copy this name. I'll come down. I'll write West build hyphen boards equal to my board name, and inside the software SDK, from where the build system has to pull out the DTSI file, which actually provides the schema for peripheral build of NRF SOC that we are using here. We have to write it in certain fashion here. So after providing the board, we have to provide the path to DTSI file as well. So the build system automatically pulls it out from the command that we are writing here. So I'll simply write slash NRF54L15, and then you have to write CPU app, because this processor which NRF54 has is M33 Cortex M33. It is a TFM enabled controller. It implements ARM's V8.1 or V8.0 instruction set that supports secure and non-secure address space. So in this case, we can actually build our code, our application in multiple modes depending on our application specific area. In this case, we are simply building a non-secure app by giving it the afterword called CPU app. So I simply write this command. It will what is it saying? Okay. Just saying this does not exist. I think I forgot to put an underscore here. No. This small typo is there. It's not board, it's board. And now yes, we can. Valid board targets are. Did we make a spelling mistake here? This is what we are supposed to do, and are we not doing this? Okay, I wrote an underscore which was not there. Just saying build.ninja is not there. Okay, when this error comes, that means the build folder was created and it contains incomplete build information. So for that we need to first remove the build folder here. So now the build directory is clean. We can give the build command again. Okay. Depending on the operating speed of your laptop, happens even faster than this. So yes, the build is complete. Now for basically showing you a working output in this session, I have already prepared one example from my existing project that will quickly show you how we actually flash the code onto the controller and see the output from the controller on this screen. So my project is in a different directory, and you can simply build the project from this location itself. What I need to do is I need to write west build. I think this needs to remain same. Then I have to provide the location of my project, which resides inside my documents folder. This. Then I have to provide the target port, which is same. Then if I want, I can provide a custom build directory as well. For that I need to use -d and then provide the location for my build folder where the build files will be kept. So I'm again providing this location here, and I'll give the name of this build directory as build_YouTube, or let's keep it YouTube_build, easier to navigate. Right now, in this example, I have created a custom project configuration file, and for passing that file into the build system, I can write it like this: -d conf_file equal to project.conf. And the thing, in this example, I'm simply printing the output onto the console, but in a real world application development, you'll be required to use the peripherals like UART, SPI, or any other protocol. So the port for those protocols and the output pins in case of NRF are defined inside a file called overlay file. So for that reason, we have to provide the location and name of the overlay file as well. So providing that, I need to basically write -d DTC_overlay_ file equal to, let me quickly see the name of the file. I forgot the name of the file. So the name of the overlay file is here. This is what I am using. And then we can start the build here. In the meantime, I can show you a glimpse of the project that we are basically running right now. So this is what we are going to run. It's a big project, but this is what we are going to see right now. And yeah, other things maybe later sometime. So our app is already built, and now for flashing it, we have to write west flash, and you have to provide the build directory here, which is located in my home folder. and we gave the name YouTube build. Now for seeing the console output using the Seger J-Link's RTT real-time trace, I have to write test RTT, and again I have to provide the location of my build directory. And then press enter. So it is flashing the board and it is saying, oh, okay, the RTT field. Oh, we forgot to provide the build directory, which is, now it will work. Yeah. So this is all for this session. This was a quick refresher about how to start using the NRF build system to make your custom applications and use this marvelous DLE enabled IoT controller for making your projects. I hope you find this helpful.